And we are recording. Welcome to the evening of Python coding. We have a serial guest here. Evelyn Ivanov gave us more than one presentation demo in the past. And today he is again showing us some cutting edge tool that is called Hugging Faces Spaces. It's actually less of a library, more like a tool, but Hugging Faces has its own libraries. But I'll let Evelyn show it, and he's showing his own application to show the Hugging Faces tool. Go ahead, Evelyn.
Okay. Yeah, so whoever kind of seen me in these meetings before knows that I'm an open source guy. I've been around open source projects for too long, and usually look for projects that have some upside and there are startups around them. Recently, we were chatting with Jacob about something, some sort of private conversation. I don't even remember, catching up, and I was telling him that there is some new progress that I'm excited about, and that's related to the realization of kind of the untapped so far limit of transformers, the transformers architecture. That it was first suggested in its current, mostly in its current form, 2017, around the time when the convolutional image networks were coming very strong, and phase detection, person detection, motion tracking was becoming really mainstream. But video was still a big problem, and speech was still a very big problem. LSTMs had a good run for almost 20 years since the original paper, but could not quite reach a state, kind of the state of confidence for image recognition, object detection to be mainstream. And it turns out that this suggested transformer architecture that came out from Google and others researchers was able to kind of end another potential winter and open a whole run of discoveries that is still not finished. It's still going strong. It's been already 4 or 5 years and it's still going strong. And it looks like the pace is accelerating. So everybody here is pretty familiar with the marketing of ChatGPT. Jacob, do you see these admit messages? People are trying to join. I don't know if I'm able to, if I'm admitting everybody.
I sometimes when I see them, I admit them. Usually I do this, but if you admit them, then I don't see them. So just go on.
I tried to do that. Just wanted to see if there is a backup person to look at them, because when I'm talking.
I am looking. Both of us are looking.
All right, appreciate it. Anyway, so everybody's kind of familiar with the cutting edge demonstrations with what ChatGPT can do, and another competition from Google and Meta and so on. But there's also this parallel trend going on that that what started off as kind of as a pledge to open source the cutting edge models has taken a 180 turn, and all these leading labs are now closing their gates. OpenAI is anything but open nowadays. They took venture capital. They sold 51% or 49% to Microsoft, raised another 10 billion. In the ChatGPT 4 paper, there is absolutely no information of the size of the model, how it was trained, very little, far less than there was for 3.5. And it seems like that's the direction. At the same time, Deep, what is it? The Google version of the London-based startup. DPI, was it DPI? Anyways, help me here. DeepMind. Okay. They also, in their new papers, specifically call out concerns of disclosures and bias and competitive factors. And I don't know if there is this Chinese and US tech war or whatever is to blame. The bottom line is that the large shops that are using tens of thousands of latest GPUs to train and burning millions per day, billions of funding to train or closing the research. So I guess we'll see where that goes. But to kind of pair that, Hugging Face, and a few other startups have emerged as open source communities. And so far, they're able to play against each other, big tech, because there is almost a rush for those of you who are following the Hugging Face evolution, a rush from a bunch of proprietary companies to open source and publish on Hugging Face new models and new breakthrough research. So we will see where things go, but from what I can tell, there is a very strong pipeline of new kind of state-of-the-art models that are actually able to perform new tasks that I have not seen done before. And I don't really have a good idea if they're too far behind the commercial models, but they're definitely ahead of what was available commercially or open source just about a year ago. And things are coming out at really fast pace. So anyway, the one that I've been playing with recently for another startup that I'm involved with relates to front-end testing and end-to-end testing of Web3 apps. As probably most of you know, Web3 apps, crypto blockchain apps are almost always involved with some sort of financial transaction. So the emphasis on security and stability and reliability of their front end, so their UI, is carries a lot more risk than an average Web2 app, which could be just a static website or something that doesn't have any financial transactions at all. So that's, the name of the startup is Guardian UI, but one of the goals here is how to make it easier to incentivize more Web3 teams to spend time on front-end testing, because that's usually a pretty overlooked area. People tend to test smart contracts and APIs on the backend, but usually the front-end testing gets overlooked. So one of the experiments here is it possible to reduce one of the big issues in front end, which is stable and simple selection of front end elements, UI elements. Whoever has done testing with Selenium or Cypress, Puppeteer, there are a bunch of front end testing tools, is familiar with the issue of how brittle tests can be, because selectors are XPath based or CSS based, or some combination, but they tend to break quickly, almost on a weekly basis, without even changing the application logic itself, because somebody pulled a third-party dependency and it changed its CSS styling. Now the path to navigating UI components broke, or there is slight designer rearrangement of the UI components, even though the logic didn't change, and that breaks all the paths. So it's pretty expensive, tedious work to be maintaining front-end tests. But there's a theme that cuts across a lot of these situations, and that is the UI the look and feel as perceived by the end user usually doesn't change a lot. If it did, then users will probably constantly concerned and they'll run away from the app. So usually the way an app looks to the end user changes gradually and slowly over time. So with that, naturally comes the question, is there a way to refer to UI components in tests in a way that a human would, right, with a natural language expression? And there's actually been work done in this area in the last few years. Let me see if I have some things here. Yeah, so there's several, not too many, but there's several papers with specialized models that just deal with that specific problem. Architectures of models that deal with UI referring expressions. Like click on the bottom of the settings button at the top right of the screen, things like that. And I looked at those. It turned out that they are pretty specialized and also built in research labs. And I spent days trying to reproduce results and eventually cut my losses and try to see if there is something simpler to solve the same problem. Like for example, the Seek to Act came out of Google, and I spent days trying to make it work on TPU. It's only designed, architected, designed, and tested on TPUs. So I spent a few days on Google Cloud trying to get it to work on TPUs and going after like fixing one build error after another build error after another build error that was left out from the documentation, and eventually cut my losses and moved on. So back to the Hugging Face reference, I guess the good thing about open source communities is that people collaborate and they share ideas of how things can be standardized and reused, recycled for many different purposes. So I found a set of models. So if you look at Hugging Face under multimodal models, and multimodal usually means text and image, or
even slow down a little bit. You showing the right things, but make it simpler for people to understand. First of all, what is Hugging Face?
Yeah, so Hugging Face is a company based in France that started off 5 years ago or so, 5-6 years ago, as a chatbot. They tried to commercialize it, did not work out. One of their co-founders experimented on the site trying to get the early version of transformers to work, and it was very frustrating, took forever, and they published in an open source repo the results that they finally managed to compile. I think they were trying to get BERT to work from 2017 or 18, whenever BERT was originally released from Microsoft. And so that got a lot of attention. And he also worked on a few other full-on transformer models, also open sourced them. And his other co-founder noticed that there is a ton more attention in the community on that than there was with their chatbot. So they dropped the chatbot, started, doubled the efforts of open sourcing and streamlining the build process for more and more transformer models. And eventually that is where they found traction and ultimately led to fundraising. A few months ago, they raised their Series C, I think, for 100 million. And in the past 6 months, there has been a rush from all sorts of communities and companies and researchers to publish in their repos new transformer models that are not compliant, but consistent and follow the best practices that Hugging Face has published of how to how to organize your model inputs, how to format the tokenization routines, input outputs for tokenization, how to tokenize images, how to handle multiple inputs from text and image to feed into a decoder, how to organize pipelines with decoders and encoders and things like that. So there's probably a good 10-ish concepts that are somewhat common for all transformers that they've standardized and have standardized their rails to put those backends on, and it made sense to a lot of people. So it's getting bigger and more popular now with more people contributing.
Now you explained what Hugging Face is. One more question before you continue. In a nutshell, what is a transformer?
I'm not a deep researcher and scientist in ML, but my understanding. Okay, so my understanding is that transformers are just the name of an architecture that extends on previous deep learning DNA models that puts a lot more emphasis on the relationship, if in a sentence or an image that is sliced into chunks, it puts a lot of emphasis on learning the relationship between how frequently certain words are close to a given word in a sentence. So for every, there is a big matrix where for every word, it has a probability matrix for every other word in the vocabulary that appears next to this word at a distance. So what is the probability that, let me take one sentence here, Corbett challenging that.
No needs, no needs. The idea is just to get them an idea. I'll help it out. I'll help you out here. The mechanism that the transformers uses mainly, as opposed to other deep learning methods, something called attention. And this attention allows you to look at the sentence and say which words are kind of related to each other. Let's not go deeper than that. There are good presentations. People can look online for this. I just wanted people to know what's a transformer. So transformer basically is an architecture that uses a lot of attention. And let's stop here and continue the next question. You're showing us multi-model models. What is this? Where does it come from? So all those models relate to Hugging Face. How does it come?
Yeah, so the original transformer architecture that beat the SOTA for a number of tasks on text proved to be doing a better job than LSTMs. I think it was originally BERT was the big demonstration, and in essence, it demonstrated that it is able to do a couple of things, right? It's able to tell you if you hide a couple of words in a sentence and you give it a sentence, it's doing better work than anybody else, any previous model on guessing what that word should be. Also, if you give it the beginning few words of a sentence, it's also doing a much better job than others to predict the rest of the words in that sentence. And so people started to experiment, can we do that with images? So replace words with pixel slices. Just break up an image into a bunch of slices and treat them as word. Would that work? And it turned out that with a little tweaking, it worked fine and demonstrated good results. Then people kept pushing it and started combining CNN type of ideas with the original transformer ideas, and were able to to get even better performance and competing pretty strongly with ResNet and YOLO V7, V8, although not as fast. But then what became very interesting is that because you can apply it to video, now they tried, can we do it to, to images, can we do it to audio? Turned out it worked for audio as well. So they tried the same thing for video. Can we treat like a bunch of, instead of paragraphs or pages, just images next one after another? Okay, that worked there too. And then the natural extension, well, what if we put these things together? If we put an image and then a text description of what that image is, can we train something to suggest what that image is, what a new unseen image contains? Well, that worked well. And then more and more crazy stuff with video and so on. And the crazy thing is that it feels like there is no yet kind of defined or proven upper limit for these things. The more you throw parameters, you make them bigger, and you throw GPUs at them, they just keep learning. They keep asking for new data, and with enough number of GPUs and training data, these things seem to be unlimitedly kind of hungry for knowledge, and they keep learning. So we'll see where that ends, but so far it's pretty impressive.
And I want to add one more thing. These are like the big stuff, but those libraries, this library that the Hugging Face gave you, actually works for fine tuning as well, and you can train them on the GPU on your own machine overnight. That it will do very nice things. You don't have to have those crazy big multi GPU thing to train something. Some tasks you can do on your own machine with those libraries. You have to have a powerful GPU, but it's still possible.
Yeah, that's another property of these transformers that people like a lot, for a good reason, that they're proving to be very good at transfer learning, which LSTMs have not been traditionally. And as Jacob said,
define transfer learning for people who don't know.
Yeah, what Jacob said a minute ago, that you can fine tune a model that's pre-trained by somebody on a ton of data with a ton of GPUs. If your data distribution is within the same kind of range of properties and set of vectors, like for example, I don't know, if we're looking at the document training. So if it was trained to recognize the structure of PDF documents, then it will learn to recognize structure of receipts with maybe a tenth of the data in the training time, stuff like that, which is actually right. And that varies, but it's on average it's pretty good at the transfer learning. So the experiment that I wanted to do is like, can we grab one of these models that have been trained on something else and use it for UI? So I picked one.
What we're looking now as multimodal models, and those models, can you characterize them a little bit?
I'm sorry?
Can you characterize the models, like the multimodal models? I see vision models, audio models, multimodal models. What do multimodal models do? They do vision and audio, or text and audio, or?
So text and image, I think, let me see. A lot of them do text and image, but some of them do audio and text.
Yeah.
And then some of them do video, multiple
and all
images.
of those are available from Hugging Faces, correct?
Correct. All of these are open source in the Hugging Face repo.
Okay.
So anyway, I picked one of those, cute name, and people have been using it for other tasks, mostly documents, OCR recognition. Oh yeah, one of the actual things that caught my attention is that it was one of the few models at the time I looked at this a few months ago that was able to demonstrate good performance on recognizing text alongside object features. So there were a bunch of models that are able to recognize what's in a picture and object detection, but they were poorly performing on text OCR extraction. And this one was one of the few that was able to demonstrate it can extract text and it can extract also object features. So yeah, the original one was trained on recognizing receipt structure and answering questions about a receipt, like what's the total or what is the price of a certain item. It's also able to pull out from PDFs charts and tell you what's on the chart and things like that. It has not been, at the time I looked at it, none of these models have been trained on UI tasks, but I figured if it's able to recognize something as complex as handwritten receipts or a ledger and be able to recognize OCR and objects, it might be able to also fine tune on UI components. And it turned out that with some time and a little bit of tweaking, it did very well actually in my perspective.
Can you increase the font a little bit more? Someone is asking. Yeah. Sorry.
So yeah, so I started playing with it to see what can be done, and it turns out it actually started producing decent results. When I shared with Jacob a version a few weeks ago, it was at something like 60% or maybe even less accuracy. As of today, the model that I have trained for these guys at Guardian, it's 90-something% accuracy. It's pretty good. It's trained on, well, let me back out a little bit. It took a lot longer than a day in one GPU. It turned out that it really depends on what data it was trained on. I think it had to relearn a lot, structures and colors and buttons and things like that are not as common in a document that's mostly black and white. But it did catch up and it continues to learn. It's been going on for several weeks and it keeps learning.
So Yulin, now that we explained approximately what we're doing, can you show what the code actually and explain what's going on? And the title that we have here today is Hugging Faces Spaces. So please explain how those spaces work.
Mm-hmm. Okay, so let me do a quick demo then of the...
Yeah, demonstrate your application, and then we'll go to the details exactly how you did this.
Okay, 1 second. Okay, so one of the things that Hugging Faces introduced is something they call spaces, where you can deploy a Gradio or Streamlit application, or you can drop in a Docker image and they'll run it for you for free on a basic CPU, which is super slow. It's a virtual shared CPU. It's super slow. But then that's how they make money. You can upgrade that hosting environment to something else. Like they give you a bunch of options here. Better CPU, better, you can get to GPUs and so on. That's how they start making money. which seems so fair. They're also providing Git repo that is upgraded to handle large files like models and data sets in the hundreds of megs and gigabytes size files. So that's pretty convenient. That's pretty cool with versioning and everything that you would normally do on a Git repo, but with smaller source files. So that's useful. Like for this particular demo, it's a simple Gradio app with, or Gradio, I'm not sure of the pronunciation. That's pretty much the gist of the app. It's pretty simple, elegant way of loading a model, pointing it to the.
Can you go a little bit? So first of all, what does Gradio do?
So Gradio is similar to Streamlit. It's a pure Python framework that makes it simple to stand up a web app without being an expert in front-end JavaScript, like React and Angular and things like that. You don't need to cross that border to stand up simple web apps that use your model. That's what Gradio is. And I think it's heavily funded by Hugging Face. I'm not sure if it's exactly their project or not, but it's pretty simple, pretty cool. It does the job. To me, it's a little bit simpler than Streamlit. Streamlit is great as well. So,
okay, so for example, load model, what does the function do?
Yeah, so that's kind of obvious what it do, right? It pointed to the repository, which is also hosted on the free open source Hugging Face repo, and that's the model that I want to use for this demo. Mm-hmm. It'll grab it. You can say which tag, which revision to pull, just like a regular Git file. I wrote a little optimization code here to cache the model so it doesn't reload all the time. That's not that essential. It's a little optimization. And then once it's loaded, set it up on the local device, CPU, GPU, whatever it is, and get it ready to perform. A little pre-processing of images that are like screenshots that are uploaded to the demo. They need to be prepared to fit the model input, like a lot of image models. Because there is this potential resizing of a screenshot to fit the image input size, respectively, once it tells you where it thinks a UI component is, it provides that in 0 to 1 relative coordinates. So there is a little bit of logic here to map it to the resized backward screenshot in its coordinates. Trivial arithmetic. And that's the main method of the demo. This is what gets hit when you submit a screenshot and a referring expression and ask it to find where the UI component is. The image screenshot and the referring expression. I made it a little bit easier for experimentation while I was testing different model training regimes to see which model did well compared to previous versions. So anyways, you can pass the revision of the model because they get checked in during training every few hours. There's a checkpoint. And because it's also, it can be used as an API as well as a web app. Added an extra parameter to say when it's an API, optionally do not return the whole block of the image, just the coordinates, because presumably whoever invoked the API already has the image, so don't blow the wire with that. So I'll load the model in here. Lowercase the prompt. It's kind of basic normalization. Prepare the image, resize if it needs to be resized. Also a little bit pre-processing of the prompt. I mentioned earlier that these transformers use tokenization to convert words into numbers, IDs, and special tokens that, like for example, structures. If you want to drive them to understand and to respond with certain structures of a response, you can use special tokens to do that instead of natural language. It makes training a little bit faster, and they don't get confused by the meaning of the natural language words versus special tokens. So, but that's minimal here. And then you ask the model to do some work. Grab the outputs, turn these tokens back into natural language or actually just natural language. In this case, we're just asking them to predict coordinates. That's it, nothing else. And
So
when
maybe you should show the application to understand this part.
You want to jump to the demo app?
We'll come back here later if there is need, because
Okay.
basically they have to understand what the application does. So just show the application, then jump back to and finish the.
Okay. So there's a bunch of examples here to play with, but you can upload your own images and.
Yeah, but what's the application? Like show them the application. Show them like a simple example.
So this is the application. This is the web app. It's a very simple web app.
Yeah, and what's the input?
So the input is a screenshot
of what?
So this model is trained on public data, which is kind of scarce, but I did find a bunch of public data for Android images, Android screenshots, and referring expressions. So that's what it's based on.
And what is it trying to do? What it sees a screenshot, and what is it trying to do?
So along with the screenshot, you also provide a referring expression like select or click on something, some UI component on that screenshot.
Okay, so and the output should be?
I'm sorry?
And the output should be?
Yeah, the output should be the predicted coordinates of that referring expression, of that component that I'm trying to refer to.
Okay, show us an example. So you're now running this example that we're seeing on screen, correct?
Exactly that. That's right.
So we should click on the arrow beside the attainment.
Beside entertainment. So entertainment, so I should click on this arrow here.
Okay, so and indeed, the adding faces, the output, it shows you the image and highlights whatever the coordinates should be of the click, correct?
That's right.
Okay,
that's right.
So the idea is that, if I understand correctly, is that in the future, if you have a user interface, instead of putting a human in front of it, that will have to click on things to make sure that it's working well, you can ask a machine to actually do the clicking for you. Just give it a set of things to do, and it will do it for you, and then you are able to test whether this is working well or not. Correct?
That's exactly right. Yeah, a lot of the front-end testing nowadays is done by outsourcing companies. A lot of Gigsters on Fiverr will do that. And a lot of companies prefer that route instead of actually writing tests because they tend to be so brittle. But the idea here is that these folks that are doing manual testing would be able to actually automate their work and make it a regression test suite that runs continuously instead of whenever they're asked to test manually.
So the idea was that you're trying to build a startup or whatever that does this, and you used the donuts model for images, and it does text as well, and you use Hugging spaces to actually run the small demo. So far, am I correct?
Absolutely, that's correct.
Okay,
That's
so
exactly right.
and if you have another application, let's say if you have another startup in your mind and you need some machine learning, then chances are you'll find some transformer in Hugging Face that can help you, and you can write a small demo in Hugging spaces, correct?
Yeah, that's the interesting part now. We're at a crossroad, right? Because the number of better models keeps growing, the community around Hugging Face keeps expanding, and at the same time you have these ridiculously inexpensive APIs for ChatGPT and whatever Google comes up with that are kind of supermodels that are able to perform a lot of different tasks with prompting. So looks like there is a path that we don't know yet where it's going to end up, but it's interesting, right? Some people are going to specialize into learning to prompt engineer and get results out of these, supermodels, and others would be working with these open source models that are smaller, but kind of uh, not tied to a commercial entity, and you can drive them in whatever direction you want. I
Interesting.
mean, yeah, ChatGPT 3.5 was all text, but 4 they're clearly pushing it to be multimodal. It's supposed not ready yet, but that's where it's going. So we'll see how good it is at solving these tasks out of the box, so you can get them without doing any training.
Oh, okay. This is interesting foresight. Let's see what actually happens. But
Right.
let's go back to the code so now people understand better what you were trying to do. And let's go back to the code and show this again because they didn't realize maybe what the things that you were aiming at. Now maybe the code can be clearer.
I mean, we're almost through the whole little app. There wasn't. Uh, yeah, that was the gist of it. Load the model, push the image,
So this is
push.
where you push the image back or when
Yeah,
you push the image into the model.
yeah, yeah. That's it. That's where you fit the model. Sorry, the screenshot and the prompt to the model, and you get out the coordinates.
And where do you put the nice image of on the coordinates? Like you just put a
Oh,
circle
the
there?
little dot.
Center point, yeah. Okay.
Uh, Here, just draw a little circle at the coordinates before you return.
And all of this is working. How much time did it take you to construct this?
Um, well, this demo app itself probably, I don't know, within a day or a couple of days. But I spent a good few weeks trying to figure out an effective way to train this thing, playing with
Yeah, yeah,
sweeps and hyperparameters.
yeah. And you were able to do this. Did you try training it on your own local hardware, or do you use the hardware they gave you?
So Hugging Face does not give you any training hardware.
Yeah. Ah, so you trained the model on your own hardware and uploaded it into GitHub,
Exactly. Into their
and
Git
then
version.
told Hugging Face, "Bring the model I trained." And how much time did you train it so far?
It's been training probably continuously for over 2 months now.
And you
On
every
a
once in a while you're putting an output somewhere. Yes.
yeah. I'll bring up the dashboard. That's right. Every few hours it commits a checkpoint. But
And you're saying it's still learning.
it's still learning. It is. Yeah,
How much?
it's running
How much?
continuously on a V100, on a single V100.
How much time does it take you one epoch? How
Um,
many? How many? How much data do you have? Let's start like this.
what is it doing? I'm trying to show you the. Let me take a screenshot. That's probably easier. Or can I can actually share this. Let me share that image, the window. 1 second. Do you see the training dashboard? Tensor
Okay.
board.
What are you showing us now?
So that's the Tensor board, the training dashboard, where, so these are the last few days here. What is it, 20th? So 2-3 days of training. This is the test metric. And now we're into the 97% of accuracy.
How many? How much data are you using? Approximately
300,000
millions of images.
390,000 total samples, which is about 15,000 screenshots with 20 on average referring expressions per screenshot.
Interesting. And each epoch takes you about again?
So
Approximately.
each epoch is about half an hour, but there are 10 in a loop. So I had to break it up because the whole thing would take a few days to go through the whole data set. To do like 10 epochs on the whole data set, it will take a few days, and you don't want to take that risk.
Your epoch is not the entire data set?
It's not, it's just 5% each epoch.
Okay, so the definition of an epoch is usually the entire data set, but you're using some sort of weird thing. So basically, you're saying about a day, let's say it like this, for to go through the entire data set, correct? Something like that.
2-3 days.
2-3 days for each data set. Okay. For
Or
the
yeah,
300,000 images. Yeah.
to go through all the images. That's right. That's right. Yeah, I break it up into even more chunks because in the earlier days of training, there was constantly needs to tweak it, and it was crashing, and it was too expensive to correct mistakes. So I broke it up, and then eventually found a cadence where it can make improvements with an epoch, grabbing just 5% randomly. Actually, I use a distribution, but let's say it's a random distribution
What GPU are you using,
in uniform.
if I may ask?
V100. It's a single V100.
How much memory?
16 gig.
Okay, so it's one of the modern ones. Pretty good one.
Yeah, I think it's the generation before the A100s, which is, I think, the latest. It's about twice as fast than the 2-3 times faster than the T4.
Okay. So maybe you haven't, unless you want to show other things, maybe we should move to questions or.
Yeah, sure. I mean, there's a bunch of other details on the training itself, but that's the gist of it. I was mostly excited that these multimodal models are pretty decent at learning different things. and they've been only around for a year or so.
It's quite powerful, I must say. I was surprised. I recently also moved to use transformers. I was surprised at how powerful they are.
Mm-hmm.
It hit me as well. So
Yeah. A lot of people are realizing that. And look at the see the loss is still at 0.6 when it has so much more to go to get to another decimal point. Like in 0, 3 zeros, 1 is when it's usually stops training, but I'm not even anywhere close to that after 2 months.
interesting. So it's still this is the training loss, or you have a validation, like you split the data to training and validation, I assume.
Yeah, the validation is this one here. See how it jumps around because it's
Yeah.
different data set every time from the total distribution. But it's trending in the right direction. I mean, it took me a while to find a good set of parameters, but let me turn on like from the early days. Hold on. So we started at over there, 0.2, and it's gradually got better
So
and
it
better.
trained quite a bit in a few days.
Yeah, in the beginning, it caught up pretty fast with the basics, and then it kept grinding.
Interesting. I must say this is a very interesting application. I hope you achieve what you wanted to do with it. And
Yeah, we'll see. We'll see. It's early days with testing with users now, like every startup does. But it's the cool thing is that now you're able to do stuff that you weren't able to even try before. Yeah, we can go to questions.
yeah. So first of all, thank you, and please let's go to questions. Let's before we go to questions. Um, uh, Please make some noise, make some reactions, whatever. Um, and then something so people know that you are listening. And even thank you for showing that this is really cutting edge. Now let's please ask questions. Go ahead, Mike.
Sorry, I wasn't reading the. There are a lot of messages here, and I missed most of them. Can somebody help me summarize? Like, where are we with messages?
Don't worry, I don't see anything that's really a question. If there's a question, usually people say
Okay.
they use the chat for all sorts of things. For me, but I I don't see any questions on the chat. But please, if anyone has any questions, and they can be simple, like there's what Evelyn showed you is really a lot. But the thing is, you can do a lot very quickly today with those set of tools.
Yeah, there
So
are tons of tutorials and very good videos. They're doing a bunch of community calls every other week or something like that. But pretty active community. Very good, high quality blog post. I think blog from Taking Face. If you want to catch up, they summarize every few weeks. They summarize the letters that they do.
So I see Mike is asking questions. What modules are you using? So you talked about the grad.io. You talked about, of course, the Hugging Faces, but what else are you using in your code? What do you import?
Let's see. So for this demo, it's mostly Gradio, Pillow, I know,
You
PyTorch.
can show the code.
Yeah, it's not on the screen. Sorry, I'm gotta switch again. Hold on. Do you see the code again?
Wait, it's coming up. Here we go. So we have regular expressions.
Okay.
We have PIL. It's the image library because you resize images. So you use PIL. Of course,
That's
math.
right. A little processing of images. Gradio is really cool. Gets you going fast with web apps. For demos, this is good enough. PyTorch,
You're using
HTML.
PyTorch. And you're using TensorBoard. I saw you using TensorBoard, so I assume you're using TensorFlow for training. But it seems that you're using PyTorch. So which are you using? Are you mixing them up?
Um, so this model was available. So Hugging Face in general, they tend to prefer PyTorch for their models. They support TensorFlow, PyTorch, JAX. I don't know what else. They support a bunch of stuff. But this particular model was built and prepared in PyTorch, so I didn't muck around with switching back and forth. I just used it the way it is and trained from there.
But the training
The
you do, but the training that you do, you use Torch as well
Yes, yeah.
with TensorBoard.
TensorBoard just visualizes the log files. So the log, I forgot now. I think it's either Lightning AI or Hugging Face, whichever. I think it's Lightning AI is the library that I'm using for training. Let me switch to that. It gives you several logging options, and one of them is to log in the format of TensorBoard.
Oh, okay. So for the training, you actually are using you're using PyTorch with TensorBoard as for visualization of training. This is interesting because TensorBoard was, as far as I know, was developed for TensorFlow, but I didn't know it can be. I know that Hugging Faces you can do multiple. I use it with TensorFlow, for example.
Yeah, it's, as long as the format, the CSV files are formatted in the way that TensorBoard wants them, it'll read them.
Okay, interesting.
Trying to find you the.
You don't have to show the entire code. I'm just
Okay.
I'm
Anyways,
just
but yeah,
curious.
there's a point where you plug in the logger into the trainer, and it'll just log all the messages for its parameters into the logger, and the logger will format into whatever format you picked. There's TensorBoard, there's weights and biases, and I don't know, a few others.
So, Mike, did he answer your question?
I mean, in terms of modules, I think Lightning AI is a good one for training. Let me.
Which one? Lightning AI you like?
Yes, so Hugging Face comes with a pretty good basic trainer, um, but Lightning AI is also very popular for a little bit more advanced training configuration. So it lets me, let me find it for you so I can go through the. So it lets me tweak the training step a little bit. It lets me tweak the validation step a little bit where I need to. What else? Yeah, it just lets you, so it gives you a bunch of the training loop packaged, but it lets you kind of drop in custom codes in the various components of a training loop as needed, right? You don't, if you go with pure PyTorch or with pure TensorFlow, you end up having to write the full training loop, which is a lot of boilerplate code. These trainers from Hugging Face are pretty much like one line. You give it the model, you give it the input data, a couple of hyperparameters, and then you let it run. That's it. Lightning
Yeah.
AI lets you configure things a little bit more.
Yeah, I must say, when I moved to my code to use transformers, it was reduced dramatically. Like the amount of code you write is, and
You
everything
mean
is
the
much, much
boilerplate, right?
simpler.
To prepare and all
And
that.
there is a nice flow to everything that they're doing. So
Mm-hmm. Yeah, I think that's one of the reasons they're becoming popular, because they streamline a lot of the boilerplate stuff.
yeah, they have good ideas. Code that I wrote, like hundreds of lines of code that are replaced by something you just like one line, and that's it. It does it better than it was before, So
Yeah.
yeah. Any more questions by anyone?
Yes.
Okay, who's speaking?
It's Beck.
Okay,
Um,
back.
I'm pretty new to the data science field, and I'm having a hard time to wrap my head around. While you're at this demo page, like whenever you uploading the image of the screen and you specifying this with words, right? Like the entertainment and find arrow on the right side. So the model extracting all the words with the coordinates for each words, like, and based on the words, like for the action call, like moves it the coordinates. Like, can you explain like a little bit, like how that action happens, like the steps that the model is taking?
Yeah, so this demo does not do any actions at all. There is a separate product that puts it together. This demo, it uses only this VLM, this visual language model, given an image and a referring expression to guess the coordinates of that component the referring expression is trying to pick. That's all it does. Right? If you're asking how this, like what...
Here, give him an example of something else. Just pick some, no, not one of the examples. Let's pick something and here, let's pick this image and change the text.
Okay. I mean, if somebody wants to send me a screenshot, I can work with that too.
Don't worry. Just do this so we'll understand. Here, Beck, there's a screenshot here.
So click
What
the tick.
what do you want to happen? Like, you think about it. You're looking at some sort of image, and you, as a user, want to click on something or do something. Which one of those images do you want to show? Like the system
Let's
to.
let's say the middle one, the center image.
Okay, so click on the center image. He just changes the text. Second image on the second row. Okay, and he submits it. What the language model does now, it was trained on many images. It tries to understand the text, and it looks at the image and tries to do what the text tells it.
Yeah.
This is what's going on. And you see it happen? You see the green dot on the center image?
Yes.
This was success. And you can give it other images and say, click on this, click on that.
Yeah, it's so Jacob makes a good point, kind of subtle there. But this one was success, right? But it's not perfect, right? It just learns over time distributions. There is ways to trick it. There is ways for it to be wrong.
So my missing point was like what you mentioned with the visual language. What was the thing you said? It transfers the image into coordinates.
The coordinates is what you see. You see
So
the
here
green thing?
You mentioned like earlier that before you feeding the images, like you need to use the VLM or something.
Yeah, VLM is the visual language model that we're using now to make this sort of prediction, to guess, putting the referring expression and the screenshot together, put them together and try to guess where is the coordinates of what I'm talking about here. Like,
so you're just simply feeding the image to the model and with the sentence, and then it makes a decision.
Exactly, and it spits out what it thinks is the kind of the center mass of that object.
So it's something like a multiple classification model.
So yeah,
So-
classification model is related. It needs to understand concepts, but on top of that, it needs to understand not only the concept of the whole image, but also its pieces. It needs to know what pieces are in the image, find them spatially where in the image, and it's also able to work with a relative relationship. So let's say one is click on this plus button at the top of the screen. Let's see if you'll get that right.
So notice it has to recognize there's something called plus somewhere, which is human language. It's not like something that the computer, you didn't tell him, look at this to that pixel. It tells the human language there's something called the plus. So the machine has to understand what the plus associated with the image and see whether it can do it. Then
Right. So yeah, this one it gets, but I'll show you something that sometimes it's wrong, right? It's still learning, and some things it has not learned yet. Let me show you one common mistake that I keep here as a demo. So we're telling it to click on the settings in the top right corner, right? Which even to a human can be confusing. Some people would say this is a menu icon. It's not a settings icon. So it also brings in the human imperfections, right? If most people call this a menu and only I call it a settings, then it wouldn't know what I'm talking about. Right, so in this case, I can help it a little bit and say it's on the right of the cloud icon. And see if it helps it ignore the specifics of being a setting and more focus on the fact that it's an icon on the right of the cloud. Like
because it doesn't know what setting is, basically.
Right, so it found it in this case, right? When I helped it and it ignored, it wasn't so focused on the fact that I call it settings, even most people call it the menu.
That's super cool.
Yeah, it's learning. Classification is kind of the base layer, and it's adding more tasks on top.
So Beck, one thing I can tell you, this is amazing what you're seeing. Because the machine understands human language and the image. Now, it's not perfect. It's far from perfect, but it's still trying to do this. This is something that people only imagined a few years ago.
Yeah, it's exactly right.
Now it's working with a few lines of code.
It's incredible that it's improved so fast with a base architecture that was invented 5 years ago, and people are still trying to figure out what the limits are of this thing.
Truly amazing. More questions? Ideas, anyone? Well, Evelyn, it seems that we left them speechless. You left them speechless.
Well, I was speechless when I saw what these things are doing without much. I mean, you remember a few years ago where we had to tinker with the layers, sequence there,
Oh,
and,
yeah.
drop out here and something there, just a bunch of alchemy. and now these things are out of the box, just able to learn. It's crazy. Sherry, you have a question. Can you make it find the icon on the right? Which icon on the right? Sherry, can you clarify which icon we're talking about? Oh,
The hamburger menu.
You mean to rename settings to hamburger menu? Let's see. It's what percentage of people in those 390,000 examples used hamburger menu to refer to this thing?
The gray box with the two darker gray icon. Gray box? I don't know which one.
See how crazy this is? That even as humans, we can't agree on referring expressions. So imagine.
Okay. Yeah, Sherry, this is interesting. How can you expect a machine to do something that we don't really understand ourselves?
Right, exactly. And all these people that have been doing the labeling, right? If they don't label consistently, like what the computer is supposed to do?
Yeah, and think about.
Yeah, it's completely confused. So I completely did not get that at all.
No, it got something in traffic. You see, it makes mistakes, just like humans, because you didn't explain what you want well. We couldn't understand. So the machine was also confused.
I mean, I can keep people bars. You can play with this. It's a public link. Let me give it to everybody to play with, so you can do it on your own. And you can. I mean, the source code of the model itself is open source. So if you want to grab it and fine tune it in any different way you want, let me share that.
So Evelyn is showing you the correct URL. You should have it in the meetup as well.
Yes, I'm giving you whatever I have here. The collab notebook is here. So the source code is here. Yeah, but that's exactly right. If people are inconsistent, then the models will be confused as well.
Yeah, Sherry's asking the question. Once I'll read the question. The question was, once it finds the icon, what should we expect it to do? Will it display something like a successful find? No, it shows us the green place where it gives us the output of the location the person asked to click. But remember, we're asking it in text and with an image. We show it an image and asking it the text, and the output is like, where should be the place to click? This is a precursor to an application. Think about a machine that does tests, and you give it lots of, you wrote software with some sort of nice user interface, and what you do is you send the screenshot of the website or whatever you application to the AI and ask him, click on this and then click on that and then do this and do the other things. So the idea is that the AI returns to you the location that the mouse click should have been, and then you actually do the mouse click, and you run the application. This is where Evelyn is going to with this, if I understand correctly.
Right. So Sherry, there is a bunch of applications for automating UI actions. Like testing is one. There is a whole industry called RPA, robotic process automation. You can research that. I'll drop the acronym here.
In a nutshell, what does it mean?
It means literally automating desktop user actions. Exactly. There is this company. It's one of the biggest in that space, UiPath. Just this one company has over $1 billion in annual revenue from automating tasks for people in office, kind of office workers that do the exact same thing every day, copy from this spreadsheet into that Word document, into that slide So they're using things like UiPath or one of the many other RPA tools to automate that.
RPA again?
Yeah, robotic process automation. It's a whole industry.
Okay. Any more questions? Questions going once? Questions going twice? Oh, Sherry has a question. The green circle is the success. Well, Evelyn?
It's the guess. It's not always a success, right? So it learns distributions like any other AI model. It just learns the relationship between certain UI components, colors, shapes, words, and the prompts. Again, the words used in these prompts, in what form, order, combinations they were used. So it essentially learns what is the highest density distribution for the combination that I'm giving it as input.
Sherry, in a nutshell, it makes mistakes just like humans,
For sure.
but hopefully less.
Right. In the GPT-4 demo, was it yesterday or a few days ago? I think that was also brought up, right? It's whatever it spits out, verify the result just like you would verify a human's recommendation. Because at the end of the day, it learns on human data, human provided data.
Okay. I guess there are no more questions unless someone else comes in and asks a question. You're welcome to ask a question. Going once. Going twice. Well, going 3 times. No more questions. So, Sherry did ask a question. What did you ask? Will you ask it to find sports? Here, let's do something funny. Ask it to find sports in the weather. Yeah.
Okay.
I don't see. There's sports. Yeah.
By the way, just send you the link so you can try anything that you want on your own.
Yeah, you can actually upload your own image. I tried.
Yeah. When
but the image
Jacob
should be
a few weeks ago, it was way worse.
Yeah, but the image should be something that knows. Well, it found traffic.
Way off.
You say it's not perfect.
Not at all. Yes, you can try. I send you the link up there.
Yeah.
Okay, I'll try that.
So, unless someone has any more questions, then we will move forward. Questions going once? Let's try Gary's. What's Gary's? Gary. That works. Gary's trying. Select sports from the menu.
No, it still did not find it. Let's see. That's wrong.
For Gary, it worked.
Okay. I mean, if you want to copy and paste here, it's the same model, so it should work here as well. I might have entered something differently.
It's a big S. I think it's a big S. You have big, small S.
It lowers all the text, so capitalization should not matter.
I assume, but for those models, it's you never know. Yeah, it actually did work.
Yeah, now that's why I mentioned earlier that there is a whole new job role coming to the market called prompt engineering. You might have heard of it. There's some people tweeting about new AI startups posting jobs for 300 grand, 200 grand, prompt engineering jobs. So learning like, what is this model trained on? What is it that it understands that I can pull out of it? Kind of meeting in the middle.
Okay, more questions. Going once. Going
Yeah, I'm not sure to
twice.
jump in actually, but I forgot which startups, but it's a called Twitter theme lately, the prompt
Yeah.
engineering theme.
Okay, I guess there are no more questions. Evelyn, we will thank you again. Please make some noise, make some,
Thank you guys.
images,
please
write
share,
something in the text. Don't go away. We're not finishing. I'm just closing the recording. We'll stay here. Evelyn, thank you.
Thank you guys.
Yeah.
Thanks for the good questions. I'll hang out a little bit. I learned a lot from people that are presenting in this meetup, so happy to give back.